So 7.2, we're talking about GCFs, so it's just a little different than what you're used to doing. Anybody remember anything about GCFs? Yeah.
Greatest common factor?
Stands for greatest common factor. Anybody other memories of GCFs?
We're trying to find the biggest thing that both of them share.
Yeah, biggest thing they share as not a multiple though. Multiples are going to get bigger. Factors are numbers that tend to be smaller. So we need some kind of a smallish number that can do what to these? Divide into them. So we need a smallish number that divides into them, but we want it to be as big as we can find. So one way to do this would be just try to list numbers that go into 45. Okay, who's some stuff that can go into 45?
9.
5 does, 9 does.
3.
3 does. How many times does 3 go in?
15.
15.
1.
1. 45. Factors tend to come in pairs. And they partner up to make 45 if you multiply. 5 times 9, 3 times 15, 1 times 45. Those are all numbers that do that. What's some stuff that goes into 63? 3. How many times?
12.
23.
21.
21.
Oops. 7.
7. How many times?
9.
9. So there's some buddies. Always
1.
1
63.
and the number itself. So that's everybody that goes into 63. That's everybody that goes into 45. So who's the greatest common factor?
9.
9. Because 9 is in both lists, and it's the biggest one in both lists. 3 was in both lists also, so was 1, but they weren't the biggest. So 9 was the champ of that game. That's a way to do it. List all the numbers that go into the one, list all the numbers that go into the other, and just look at your lists and find the biggest one. Question about that? Here's another strategy that we could use to do this. Another strategy you could use to do this is do some factor trees. So with 45, we'd get
5 and 9.
5 and 9. With 9, we'd get
33.
3. 63, we'd go
7 and 9.
7 and 9. 9 gives you
3 and 3.
3s. Then look for who's in common. Who's in both lists.
9 and 3.
Don't look at the upper levels, just look at the lowest branches.
3.
3s. This 3 is in common with this 3. That 3 is in common with that 3. And 3 times 3 makes 9. And we already decided the answer was going to be 9. That's another way you could do that. Question about that. I think what more people tend to do is a little bit of a guess check. Hope that the number just comes to you from heaven. What number goes into these? 9. And then you kind of sometimes have to wonder, is 9 the highest number that does that? But if you know your 9 times tables, 9 goes into this, how many times?
7.
7. 9 into this goes 5. To verify that 9 is right, you could ask yourself, can anything other than 1 go into these? Both? No. So that means 9 is the correct answer. This is a word called relatively prime. Nothing goes into these except for 1. Those are called relatively prime numbers. Compared to each other, they just don't have any common factors. But 9 is what we want to hit. Question about that? So here, you could make a list for 18, you could make a list for 28. I don't really want to do that. We could do factor trees for 18, we could do factor trees for 28. I don't really want to do that. If that's a better way for you, then that's what you should do. What I tend to do more is just try to think of something that goes into both of these. Can you think of anything that goes into both of these?
2.
2. So 2 is in the running to be my answer, but I want to verify that. 2 into 18
9.
is 9. 2 into 28
14.
is 14. Can anybody go into 9 that also goes into 14? No. So 2 is correct. Question about that? So let's go again. Think of anybody that goes into these.
10.
10. 10 definitely goes into both because they end in 0. So 10 into this goes 6. 10 into that goes 8. Can anything go into 6 and 8 both? Yes, who?
2.
2. So that's not right. But since 2 is the number we just said, take this times 2. And now we're looking at 20. Right after we heard 10, I heard a 20. If we had guessed 20 from the beginning, 20 into this is 4. 20 into this is 3. Can anybody go into both 3 and 4? No. So that would have verified 20 is right. That's, I think, the quickest way to do it. You guess something that you think might be right, and then you verify by just dividing and making sure. Something about that. 48 and 72?
12.
Okay, 12 does go into both. 12 into this goes 6. 12 into this goes
4.
4. Can anybody go into 4 and 6?
2
Yes, 2. So take this
times 2.
times that extra 2, 24 is the hit. If we had done 24 in the beginning, we'd have gotten 3 and 2 and been done. Something about that. Okay, 36 and 72.
12.
12 is in the running. 12 into this is 3. 12 into this, 6. Can anybody go into 3 and 6? 3. So take this
So 36.
times 3 and it's 36. Sometimes you can get the littler number on the list. If the littler number can go into the big number. That's like the biggest it can ever go. If you ever had a desperate moment and nothing seemed to work, who could bail you out?
The number itself.
No. If I gave you something like 19 and 58, you're like, there's nothing that goes in at 19 and 58. Yeah, there is.
1.
1. So sometimes you can get forced to go as low as 1. Sometimes you can get high as the little number. If little goes into big, use the little number. If nothing seems to work, just use 1, and that's something. Question about those? Then we got something with a mix of numbers and letters. Yeah. If we get a mix of numbers and variables, do the numbers the same way. So with 9 and 6
3.
is 3. And then here's what we're going to go for with the variables. When there's variables, you want to pick the lowest that you can see. So since this has an x, and this has a bunch of x's, take the x, because that's lower. Whatever the lower of the two is, take the lower one. That is new to your life. The only way you've seen that before is maybe in 7th grade, if you remember people working on folders in the back. Some of the folders in the back played this game with you guys. It's this exact lesson was in a folder back there. You're smiling. You remember doing that a little? Like it existed. Maybe not how to, but it's like you've seen this before probably. So for this, numbers, just do what we were doing. 12 and 18, use our number.
6.
6 goes into both.
And then x squared.
We go x squared because that's the lower of the two. 16 and 20.
4.
4.
X to
X
the
like?
X to the first.
Just an x to the first from that one. Y's?
To the fourth.
4, because they both had 4, so just take the 4 of them.
Just
And then a regular old 16. And that's going to be, I believe, the first half of the homework is playing that game. Let me take a peek at the page, make sure I'm saying right advice to you. 276. Yeah, the first section of homework will say find the GCF. That'll take us like through the first group there. Question there. Then we're going to use that and go a step further. So there's a new thing to your life called factoring a GCF. So the first thing you have to do to factor a GCF is figure out the GCF, like what we were just doing. So if I look at 6 and 9, we pick
36.
3. Thinking little, you with the 3?
Yeah.
Okay. And then if there's an x versus no x, take the lower one, which is
2x? No.
not an x. So if this has an x and this doesn't, we just don't get to take an x. And what we're looking to do is create ourselves basically a distributing problem. We're distributing backwards. But the first step of this is plot the GCF and plot the GCF down in front of the parentheses we're going to make. Question about picking the 3, the way we've been doing pick a GCF so far. Okay. Distributing is what? Adding, subtracting, multiplying, or dividing. What are you doing when you distribute? You're multiplying. So if we're undoing that, we must be dividing. So you take what you had and you divide by the GCF. So 6 dividing 3, 2. 9 dividing 3, 3. We see a plus, so just don't mess with that. And who else was sitting there? An X. So that is like undistributed, if that's a word, which I don't think it is. If you wanted to check it, you could just distribute it right back. If you distribute this right back, you get right back to where you started. But we're undoing distributing. The rest of this chapter, we're going to undo a lot of things that you're getting used to doing. You got pretty good at foiling. We're going to be like unfoiling. There's just some things like that we've been doing that we're going to like reverse it back. Question about that first one? Can you turn me to the next column? We'll just keep doing the same thing. So phase 1 is, let's pick a GCF. So I think I'm just going to roll down through here and just pick our GCFs. So number on this is 5. Let's go number on this, 3. Number on all of those numbers, 2. Number on this, 8. And there's no number to even have on that. Question about the number picking part. We could, but then we could make it invisible in the answer too. So an invisible one wouldn't help or hurt us really, it's just sort of there. Then let's pick out Z's. Z life on this. Just the one I committed to. X is here. This I believe is a sloppy 2. So we go X2. Y life.
Y.
Just a Y. X life. Just an X and just a Y. X life.
No.
None of them. Why none of them?
Just one has an X and one doesn't.
One had an X and the 8 didn't. So if we've got nothing there, we got to go with nothing. X life here. 10 of them. Question about the pick the GCF in the beginning, like what we were doing in the other column before we turned. And then what did we say is happening in the parentheses for creating? We're dividing. So let's divide all the numbers. 10 would become 2, 25, 5, and I'll just leave the sign to fill. 1, which can be invisible or written. I'm going to leave it at, I'll write it. 15 is 5, 8, so 4. I'm going to make that a little longer. 4 is 2, 2 is 1. Need some signs there. Keep that minus alive up there. 2, 1, plus, and then here there were no numbers, I'll just pencil in the plus. Question about number management for division. And then here's a theme from last chapter. Division with powers. What have we been doing division with powers? Subtracting the powers. So this had a Z, and we took it off, so there shouldn't be any left. This had a double Z. We took 1 off, so it should still have 1 Z. Triple X took off a double X. So X, single Y, took it off.
No Y.
Nothing. X squared, took off X squared.
No.
Nothing. Y to the 4th, took off a Y.
Y to the third.
Y to the 3rd. Anything about that? Okay, so what would be here for X's and Y's?
X. X and Y.
1x, 1y. This had doubles of both. We took off one of both. It leaves us one of both. How about for that zone?
None.
Nothing. Just leave the 2 with no variables left.
1y.
There'd be an extra y left. Here,
X.
an x. There,
No.
no. Here,
2. X.
in that first slot,
Nothing.
nothing really with x's.
Is that the 2x?
There's where there's an x to the 2. But here we can't just have this empty space. We've got to have somebody who's there.
A 1?
That's the invisible. We've got to use an invisible 1 there. So her idea of invisible 1s, it was necessary. Everywhere there used to be something, there still has to be something. If you have an item and you took all of it, remember what we're doing is, that's correct, multiply, divide.
Multiply.
Subtract.
Divide.
What we're doing is dividing, which if there's powers makes us
Subtract.
subtract. But if we have an item and we take it off, we divided it off, anything divided by itself makes
So,
Makes it a 1.
a 1. Like this divided itself, that's a 1. This divided itself, that's a 1. When something divides itself, you are going to get some 1s. But that's it. Distributing the other way, like I said, he said, we said, you could just distribute to check them all, and it would all return back to where it had been. Anybody a question before we wrap up what the homework is and close it down? So 276 is where we live. There's a 1 to 26. The first section is like this, just bind to GCF. The second section is like this, where what it says is factor. And that's going to be a word you want to get used to seeing. When it says factor numbers, that's like your factor trees. But now that it's starting to say factor algebra stuff, for today, it's going to undistribute. But for future days, it's going to unfoil and undo some other things for us, and that's where life's about to go. But 276, we're 1 to 76. First 8, do that. Next group, factor this GCF thing. And that's a wrap.